take it away, and glad you're with us again, Sergio.
All right. Okay. So let's start. LibRIST TUN. Who needs exciting when it just works, right? So the point here is there comes a point in the lifetime of all software at which point it's no longer new and exciting. It becomes mundane, boring, right? Well, but that's a good thing. It means that it works. It has reached maturity. So along those lines, boring is beautiful, right? The maturity is there, and now we're expanding and adding bells and whistles to the software that we have, that runs the protocol. The TUN feature really is just a tiny extension of functionality. The RIST main profile already depends on a GRE tunnel. All we're doing with this feature is extending it so that the user can take advantage of IP tunneling. If you're not familiar with TUN, it's essentially virtual private networking within user space, as opposed to an operating system level tunnel. In the demo, we'll demonstrate a task that complements the video stream transmission. We have a security camera mounted right here above me, and we'll run the pan tilt zoom software, the PTZ software, that controls the camera through the IP tunnel. The point is to give our viewers today some ideas for other workflows that have to do with their work scenarios in particular. Okay, I'm not sure Zoom will do this demo justice. We'll see. Here's a quick diagram. The camera is connected on the same network as the RIST sender. My laptop, which has a Zoom call and is running the RIST receiver, is on a totally different network. As a matter of fact, it's on a different ISP altogether. I have two ISP links. We will see how with just a few operating system commands, we'll set up a tunnel. Now, the PTZ software is a Microsoft Windows application, and my laptop is a Linux laptop. So we'll be running that software on the DeWine emulator. The software will reach across the RIST tunnel and control the camera and everything related to the PTZ commands. All right. For those who are familiar with the LibRIST, we added two new options to the command lines of the RIST sender and RIST receiver. Today, we'll set up the TUN interfaces manually rather than have LibRIST create them to make things more transparent. In this slide, you can see the list of commands needed on the sender to create the tunnel, configure it, or the TUN interface configured, and the actual RIST sender command line itself. Here you can see the standard help screen for the RIST command line, and we've highlighted in yellow the two new options that show up with this new feature. The tunnel itself, once you create it, can be configured in three different ways. The TUN mode 0 will basically forward all protocols across the link. TUN mode 1 will allow all protocols except UDP, and if you use mode 2, you can only tunnel UDP data. They all have their uses. So let's go ahead and jump to the demo. First, I'm going to switch over to a console that's connected to the RIST sender machine. So let me go to the RIST sender machine. Boom. So I'm logged into that RIST sender machine that is in the other network next to the camera. So we're going to create the TUN interfaces. I have my little script here that I'm going to just show it so that I can copy and paste the commands. First, I'm going to create the TUN interface. Then I'm going to go ahead and assign an IP address to it and a subnet, private subnet. I'm going to change the MTU to 1400 so that I don't get fragmentation. And now I'm going to bring the TUN interface app on that remote machine. Okay. Now, if we were only trying to get to a camera or encoder at the endpoint where the RIST sender is, we will be ready to start the RIST sender. However, in this case, the camera is a separate machine connected to another interface on the RIST sender itself. So we need to perform some routing magic, I guess. In this case, that magic is called proxy ARP. Okay, so I'm going to show you what it takes. It's not a lot of stuff. You just need to know a little bit of networking. we turn on IP forwarding for that Linux machine. We enable the proxy ARP feature of the Linux kernel on the two interfaces that are going to be sort of bridged together. It's a way of bridging without actually a bridge device. And we need a route for the IP of the camera. That's it. Now we've configured the tunnel, we configure the proxy ARP routing, and the last step is we start the RIST sender. So I have a little script here. I'm going to go ahead and start it. So RIST sender is ready. So now I'm going to switch to my console on my laptop, which is a receiver, and perform the same actions. First, I have to create a tunnel manually, a tunnel interface, a TUN interface, so not a tunnel. So let's do that. Assign an IP to the tunnel. And bring the tunnel interface up. All right. Okay, now I'm going to start the RIST receiver. Here I don't need any proxy or anything else. I just need the RIST receiver directly because the software is running from the same machine. Go ahead and run it. Okay, so now we can confirm that our RIST connection is established with our new TUN command line parameters. Now that we see it's running, I should be able to get to the camera directly through the remote IP of the camera that is on the network that we've been using for all this, which is the 192.168.101 network. So I'm going to go ahead and open VLC. And I already have the RTSP link to the camera, which I know that the camera I can use this RTSP link to play it. So let me go ahead and click it. All right, there it is. So now you see the PTC up here. And this is the high bit rate, high quality link. Basically, the RTSP command, when VLC uses it to talk to the camera, it performs an HTTP handshake with the camera, and then the video is pulled using UDP. And because it's UDP, it goes over the RIST part of the connection automatically. So we get a high quality stream that started with a two-way handshake on RTSP, which is HTTP, that went through the tunnel. And all this is transparently without having to configure any individual stream through the connection. So next, I'm going to open the software for the PTC camera. Remember, this is a Windows application, so this is really running Wine emulation. There it is. I just opened the software. This is the PTC software. And you can see first, the camera was automatically detected. It shows up. And let me go ahead and open. And I'm going to grab the camera and I'm going to just bring a substream. I'm not going to bring the main, and I'll explain why. So there. I brought this substream because I know that this software uses HTTP to bring the frames, which is very inefficient, right, across an internet link, as we all know. Congestion and latency creeps in. But by opening the substream, I can still see the video with only 200 kbps, and I can control the PTC, which is the whole purpose. How do I send the PTC commands to the camera? So let me show you here. Turn left, turn right, very boring. Zoom in, zoom out, but you know, it's needed. This level of control is needed, and you couldn't do it if you didn't have the TUN IP connection as well. And if you notice, whenever I move in the PTC, I have almost real time on this one, because it's a very low latency TCP connection. And then a second behind, the other video moves, which is our high quality UDP transmission that's coming over RIST. 200K versus 4 or 5 megabits per second on the second one. All right. By the way, the camera I'm using is Alhua is a brand, and the software is pretty standard. Almost all these cameras have similar software, and the protocols are compatible between them. Let's see how I'm on time. Okay. All right. So needless to say, and let me bring back some of the video here. You can run, or we can run, any kind of software that communicates via IP networking over that tunnel interface. If you think about applications that complement a video stream, you might, for example, run a private chat channel for conveying directions in response to something that you see in the video, or maybe use the private channel to trigger commercial insertion through an API. The point is that a feature like this TUN support can fuel a real world use. You don't have to develop anything, it just works. All right. So just to summarize what we just saw, it's just LibRIST with the ability for user-space networking apps to work across RIST-connected devices, right? So now it's not only the video stream. When you enable this feature, you can talk to the remote device with any protocol. This slide just shows the importance and the security and the encryption. It's just a reiteration of the security considerations we already mentioned, so we can skip to the next slide. So what can we do with this functionality? What other things we can do? You have multiple peer support, authentication in all sorts of ways, perhaps a decentralized control room or command centers that span many locations. You can automatically create an SD-WAN between all your endpoints. The point is, you don't need a tunnel anymore. No tunnel software is required for any of these applications. So one caveat here, the current implementation is for Linux or Macs or Mac OS. We don't have it on the Windows yet. Even though Windows has the tap interface, it's part of OpenVPN. In Windows, it cannot be used in TUN mode. It has to be used in what's called tap mode, which is a layer 2 protocol. So we're going to look into alternatives for Windows, like a software called WinTUN that I was made aware of just recently, to see if we can add also support for this functionality under Windows. So that's all. Thanks for attending this presentation, and may you find LibRIST to be boringly useful for your own projects. Thank you.
Wonderful. Sergio, thank you so much for your presentation. And yeah, in a way, we want this to be boring, right? We want it to just work. But on the other hand, I know that the RIST group is working to add functionality all the time. So while it may be boring and that it just works, continue to watch this space and look for presentations from our colleagues like Sergio and others about new functions as that comes along.